Hi everyone, today we're going to kick off our Unit 8 with probability. Specifically, we're going to discuss theoretical probability today. So theoretical probability has a formula to it. It's different than experimental. Experimental probability is when you carry out an experiment, say you throw a coin 20 times and then you record the exact data. How many times you got heads, how many times you got tails, and that gives you your experimental probability. Theoretical probability can be summed up with a formula. So it's the idea of the number of favorable outcomes, so the outcomes that you want, over the number of possible outcomes that there are available to you in any experiment. So we can also simplify it by P equals FO over PO. So to discuss theoretical probability and to show an exemplar for it today, we'll do two of them. Let's say we had an experiment where we toss 3 coins in a row, and we wish to see 1 head and 2 tails being tossed on between those 3 tosses. We've got this chart here to record the different possibilities. What is the probability of this occurring? So again, we're going to figure out the theoretical. I'm not actually going to toss 3 coins X amount of times to figure it out. That would be experimental. Theoretical is, in theory, what is the probability of this exact situation happening? So let's say we toss the first coin and it's a heads. We're going to represent that with the gray here and an H. So there's a possibility that the next coin we flip is also a heads. But there's also a possibility that the second coin is a tails. There's only those 2 on the second coin. Now if we go into the third, let's say we toss a heads the first time, a heads the second, we might toss a heads the third. Or instead of a heads and a heads, we might toss a tails on the third. And then vice versa for the tails being the second throw. If we did a heads on the first, a tails on the second, we might get another heads, or we might get another tails. That equals 4 unique outcomes. Heads, 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 tails, heads, tails, heads, heads, tails, tails. We'll put that up on the screen in a little bit. The next one is, let's say we flip the first coin and it's not a heads, it's a tails. So then we have the potential to flip a heads the second time or a tails the second time. And just like the first bit here, the third coin could be a tails, heads, heads, or a tails, heads, tails, 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 heads, tails, tails, tails. So we also have another 4 outcomes. So remember that theoretical probability is calculated by probability equals the number of favorable outcomes versus the amount of potential or possible outcomes. So we have 8 potential outcomes in total. We don't know the number of favorable yet. We'll have to add that up. Again, the favorable is 1 head and 2 tails on any given 3 tosses. So right now we've got the bottom part here. So let's actually go through the outcomes specifically and see how many of these actually equal the 1 head and 2 tail scenarios. So I'm just going to pull this up again. So these were our possible tosses and scenarios. So we've got 1 here. This is 1 heads and 2 tails. 1 down here, 2 tails and a head, and 1 head and 2 tails. So in total, out of all of these 8 outcomes, we actually only have 3 that are our favorable outcomes, the outcomes that we want. So the probability of getting a head and 2 tails when flipping a coin 3 times is 3/8. In the real world, in experimental, it may not be that easy. It may be less, it may be more, depending on, the idea of chance and luck. But for theoretical, this is how we would compute it. So let's just do a quick question, moving away from the coin toss, and just look how we would solve it using the formula. So let's say we have a bag, and in that bag, we have 10 red marbles, 6 green marbles, and 4 yellow marbles. What is the theoretical probability of pulling out a green on your first try? Like, you put your hand in, you don't look, you pull out a marble. What's the probability that it's going to be green, theoretically? So once again, it equals the favorable outcomes over the possible. So we know we have 6 green marbles. So that's the number of favorable outcomes. There's 6 possibilities for us to get what we want, but there's 20 marbles in total. 10 plus 6 plus 4 is 20. And so yeah, it's 6 over 20 is our probability. We always want to reduce to the lowest terms. We're using fairly small numbers right now, but it's kind of the same thing we talked about with fractions, where sometimes the larger fractions can be a little confusing to the average person, or fractions can be confusing without percentages. I think most people understand percentages better because of the limitation of up to 100, right? A full 100%. It's the same thing with the probability fractions. We want to make it as low as possible so that it makes sense to people. If you remember to put a fraction to its lowest terms, we have to find a factor that can be divided into both the numerator and the denominator, and we keep rinse and repeating this method until we can no longer do it. 2 is a factor of 6 and 20, which makes 3 over 10, and there is no number that goes into both 3 and 10. So the theoretical probability of getting a green on your first try, in this case, would be 3 over 10.